Welcome you all. Today we are going to discuss about quick sort from the divide and conquer approach. So we already know what do you mean by divide and conquer approach. We are going to divide the problems into number of sub-problems and we are going to solve each and every sub-problem individually and finally going to combine the solutions. Okay. So these are the steps to be followed in quick sort. Number one is I have to select and pivot element, then the partition steps will be done and I have to repeat the step recursively for each and every sub-problems that has been partitioned and then I have to combine the solution at the end. For that I have taken an example of set of elements of 9. First I have chosen the pivot element as 40. Okay, so the initial element is taken as the pivot. The pivot can be either it can be a starting element or at the end element or a middle element. It's absolutely depends on the choice of the user, whoever is solving the problem. Here I have taken 40 as the pivot element, that is the starting value, and then I have to initialize the value of I and j. The immediate element next to the pivot is taken as the I value and the last element in my list is taken as the j value. I have to repeat the process. What are all the steps I have to repeat is I have to increment the value of I until the value in that particular position should be greater than pivot, and I have to decrement the value of j until I found an element which is less than the pivot. So now the position in I, the value in I is 90, it is found to be greater than pivot, so I am not going to further increment it. So I am fixing the position of I. Here j I have 50 which is not found to be less than pivot element, so I am decrementing it further. Now j comes here, here is found to be 45, it is not less than pivot element. Then j comes here, now the new position of j is here. So after decrementing, now here I found out that the j element, that is 20, is found to be less than 40. Once I found an I element greater than 40 and j element less than 20, I have to check whether the I value is greater than is less than j or not. If it is less than j, the position of the I value is less than j, then I have to perform the swapping operation of I and j. So swapping operation of I and j happens. So the element 20 goes to the position of 90 and 90 goes to 20. Again I have to repeat the same process. So again I am incrementing I found out 60 is found to be greater than 40 and I am decrementing j, I found 10 is less than the 40. Again since I is less than j, I am swapping both the elements. So 10 comes here and 60 goes there. Again I am repeating the process and I is incremented, I is incremented. Here I have 5 is not found to be greater than 40. Again decrementing I is 13, not found to be greater than 40. Again incrementing I, it's found to be 60, it is greater than 40. Then I am decrementing j. So this j is found to be, j is not found to be less than 40. So I am again decrementing j. Now I got 13 which is found to be less than 40. When I am checking the value of I and j, I value is greater than j. So whenever I value is greater than j, I have to swap pivot and the j element. So what are all the elements I am going to swap is 13 and 40. So once the swapping of this pivot element happens, I have to divide, partition occurs here. I have to take the left elements as the separate subproblem and right set of elements as the separate subproblem, and I have to repeat the same process whatever I have done before. Once after performing this, I have to combine the solutions. So this is what done in your quick sort. So that is what given depicted in an algorithm format. See here I am repeating the incrementing of I process and until I found I of I greater than or equal to P, and decrementing j value until I found A of j less than P. Once I found that, I am swapping the A and j. When I am swapping the A and pivot element, j and pivot element, partition occurs. So that's what depicted in the pseudocode here. Quick sort of A of left element and quick sort of A of right side set of elements. So I'm going to repeat the same process that has been given in an algorithm format. So now we are going to analyze the quicksort best case analysis. So the best case for quicksort is given here and worst case. So worst case is big theta of n square. So that's all about your quicksort. Thank you.